Our project, FREE, with this acronym, From Research to Enterprise, has been supported by a Central Europe program. University of Debrecen was the lead partner in this consortium, with 7 partners from different countries. These countries were Poland, Italy, Slovenia, Czech Republic, and Hungary. The main aim of this project was to develop certain databases about available research. This is what we call a research directory. This has been a brand new initiative in this respect in Hungary and also in other countries. Here we gather data about research groups and also research supporting agencies. This is freely searchable. Contains public data, publicly available data, and we hope that it will help to connect research enterprises with universities. In fact, it is going to be a very good tool for technology transfer. In this project, the other important factor was to find out the good practices. We summarized these in research guidebooks, which contained the best practices in different countries. And we try to implement those at our university, at our partners. And also we make it also publicly available. And we hope that the decision makers will implement some of these good practices in their future decisions. Also, since this program is about technology transfer and we find extremely important to train our partners or friends, we conducted several trainings during these 3 years, also in Hungary and in other participating countries. On these trainings, mainly technology transfer officers participated and they learned a lot, I believe, from the technology transfer they held this year in May in Brussels, and also from our training that was held in October with participation of several technology transfer offices from Hungary. There, the invited lecturers were from the United States, from Germany, and also from the Netherlands.
The Biomolecular Interaction Laboratory uses 2 devices to quantitatively determine biomolecular interactions. This type of interaction analysis is very useful for basic research because it helps to identify important signaling complexes in biology. But it is also used by pharmaceutical research because the protein-protein, the protein ligand, and the protein-lipid interactions are very important in drug analysis and design.
My name is József Prokis. I'm a chemist. I work here at the University of Debrecen, And my work is the analytical chemistry. I started to measure different chemical form of selenium, here what is called speciation. Anyway, and some years ago we had a nice discovery, what resulted a new patent, because we realized if we add some inorganic selenium, what could be toxic for the humans if we overdose that to the bacteria has a special detoxification mechanism which result a new form of selenium, what is called nanoselenium or elemental selenium in a bacteria. And this form is really suitable for making food and feed products which are enriched with selenium. Selenium is a very important microelement. It is essential for the humans. If we don't have enough selenium in our feed and food, in that case we will have cancer in higher risk, or heart disease, or it has a special role in the working of thyroid hormones.
We are interested in a cell type which reserved its functional properties from very primitive creatures. But of course they acquired also new possibilities for regulating the immune system. The cell type is referred to as dendritic cells, and these cells can be found in the human beings almost in every tissues at a very low number. The major goal is to try to manipulate these multifunctional and very interesting cells in a way that they can modulate the immune response either to silencing damaging inflammatory reactions or to support the efficacy of vaccines which can induce a protective immune response against viruses or tumor cells.
In 2006, we discovered together with Dr. Geist at the Semmelweis University in Budapest a new adaptor protein which we named HOFI, due to the fact that it was homologous to a protein known in tumor development which was called FISH.
Activated dendritic cells are able to induce immune responses against not only pathogens, tumor cells, but also against pollen grains. We have discovered a few years ago that hydrated pollen grains are able to produce reactive oxygen species due to a specific enzyme activity in them.
Aerogels are the lightest solids on Earth. They are characterized by very, very low density. Their porosity is extremely high. They are surprisingly strong. These materials are extremely good heat insulators. So far, aerogels are used in different kind of fields in the research and industry. In this laboratory, we have developed a new technology which is now filed for patent application. Composites are a mixture of two different kind of materials. The matrix is aerogel, and the dispersed particle can be any kind of solids, can be even a liquid or a gas. One of the possible application is, for example, the construction industry. We have produced an aerogel composite which can hold 17,000 times of its original weight. We have also developed very special nano composites for optical applications. Besides the shielding properties, it's also a heat insulator. We have also developed a continuous production technology which lets us to make virtually unlimited quantity of these aerogel composites in a very short period of time.
The Proteomics Core facility was established in 2005 and is located in the rapidly developing Medical and Health Science Center of the University of Debrecen. The lab is part of the Research Center for Molecular Medicine, Center of Excellence of the European Union, and the Department of Biochemistry and Molecular Biology of the university. The lab is dedicated to study post-translational modifications of the proteins, mainly helping the researchers of the University of Debrecen and also the industrial field, the biotech companies. Our mission is to undertake research and to provide with analytical services on the field of mass spectrometry and two-dimensional electrophoresis for the different research groups and the biotech companies, and also to provide access to these services.
So this laboratory belongs to one of the incubator houses of the University of Debrecen. The name of the laboratory is Industrial Fermentation and Biotechnology Laboratory, and the profile of the laboratory is a small-scale fermentation technology and strain improvement of microorganisms used by the industrial biotechnological sector. It was built some 4.5 years ago. The reason for building this lab was that in this region of the country, the industrial biotechnology is rather well developed. There are several companies in the region which are producing antibiotics, acids, amino acids, all kinds of pharmaceutical stuff, and therefore we hypothesize that this lab will have a certain amount of market. And as a consequence, we have built a lab where more than a dozen small-scale and medium-scale fermenters are available, and we have built another lab which consists of several equipments and all the tools, all the protocols which are required for molecular strain improvement in the pharmaceutical and biotechnological industry.
Hello, welcome to Analab Ltd. This is an analytical laboratory situated at the University of Debrecen. We are an independent entity, but we are very closely related to the Inorganic and Analytical Chemistry department of the university. We are a service-providing laboratory which covers various things. Main area where we are working is environmental analysis of water and soil samples. The other very important area is the cooperation with the pharmaceutical industry. Another area is the service that we are providing for industrial partners. In cooperation with the university, me and my colleagues were taking part from the educational work.